Un, deux. Good afternoon to all of you, and thank you for coming to our presentation on equipment qualification with a specific focus on SMRs and AMRs. So my name is Eric Dagan. I'm with Bureau Veritas. I'm a project development director, especially with AMR and SMR technologies. And today I'm here with Nicolas Tillozen from Framatome Technical Center. He's a sales manager. So we're going to present you what we think are the challenges and the potential solutions and the steps that you need to go through to secure equipment qualification for AMRs and SMRs. Let me start briefly with an introduction on the Equal Alliance. So, and then I will explain what are the equipment qualification approaches for AMR and SMR requirements, and we'll finish with the conclusions, and then we'll welcome your questions. Initially, we launched this team of capacities, capabilities, expertise, which is called Equal, to address the specific needs of equipment qualification, with no intent to focus on SMR, because that was a couple of years ago, so it was not as hot as it is today with all the technology providers that you have probably been visiting during the WNE, so it's quite new, this AMR and SMR thing. But that's the combination of expertise from Framatome, Bureau Veritas, and you probably know us as a testing, inspection, certification body. Together with Altrad Babcock and Serap and Atron. And we combine some diverse expertise in the field of engineering, testing, technical assistance, knowledge of codes and standards and regulations. We've got also experience in product certification, and as well as training. So that was our initial goal, to offer that suite of services to our customers. And we also have a partnership with the University of Bristol for some specific activities that we cannot deliver as we are today. So we want to combine expertise from all the experts that we have in-house in our different organizations. So I just quickly introduce the companies, but really it's about getting all the experience that we have in all companies. We have also a specific project organization. We address equipment qualification as a project because it involves very different activities and it needs to be managed as a project over years. It's not a short time frame activity. We also want to be close to customers, so we have this global footprint in France, in Germany, in the UK, and worldwide if necessary. And then we want to make sure we have the right approach. It can be an expensive activity, so we want to limit the expensive tasks as much as possible. So if we can rely on existing qualification data, that's what we prefer, but we need to check that. And then we, of course, define every time a specific qualification approach, depending on the specifications, regulations, and that's our approach. So in terms of SMRs and AMRs, we identified, let's say, issues, as we call them. First of all, there is a large variety of regulations, and regulators sometimes don't have a clue of what they expect in terms of equipment qualification. So that is a challenge. There is no regulation or there is no technical specification, especially with the newcomers, those countries. There will be certainly a shortage of testing capacity. We see that coming. because we've got new materials, new equipment, there is no existing OPEX, operating data. So there will be a high demand for testing, and we foresee certainly a competition, sort of competition between technologies for testing capacities. Also, because we're talking about SMRs and modularity and cheaper technology, probably more commercial grade items that will be integrated in safety systems. So how do we approach that? How can we rely on commercial grade items? Shortage of suitably qualified personnel for equipment qualification. Configuration control changes. We can expect that to disturb the qualification process, so we need to find a way to make that smart. Like I said, lack of OPEX data, more complex life cycles, so we'll see objects with fresh fuel, used fuel. How do we consider these different life cycles phases, which we don't normally have for large power scale reactors. And also multiple and challenging environmental conditions, different sites, different environments. So this is going to change the game a little bit in terms of equipment qualification. I'd like Nicolas to, let's say, explain and take you through the qualification process, the overview of the process. Nicolas?
With pleasure. Thank you, Eric. So here on this slide, we stay one more minute on a general process for equipment qualification that is valid till now, that will also be valid in the future for the SMRs and AMRs. Equipment qualification is a requirement by the safety authorities. This is the starting point, and it shall confirm that the equipment of being capable to meet the requirements for performing safety function while subject to the environmental conditions. So you can see the cycle that can be followed, starting with the requirements from the national regulations, from the codes and standards, contracts, and all the PIEs, so the BCDEC conditions that you can have under local conditions. And at this stage, it's quite important to also understand these requirements. This is sometimes something that you can see in larger projects. You are having requirements that are sometimes defined for a certain area, but you need to understand the requirements on the equipment to be qualified. And sometimes you need to analyze the difference. So understanding the requirements is the first stage, but it's a central one. And many times, if you do not it correctly, you do all the remaining works and you state, and maybe you were too conservative, and you fail, and it was not necessary. This was the step requirements. Then we are going to the qualification strategy. And this is one of the steps at which the experience is absolutely key. What do we know? We have what we have qualified so far. I will show the example afterwards. On Framatome side, we are having a qualification databases in which all the informations are stored on the big campaigns also we performed on Framatome side, for example, for the EPR. It's a big databases of all the qualifications files that we are having so far. And then the first step would be, if we are thinking on a SMR, to check the difference, to check the delta, and from that point, prepare a qualification plan, a qualification strategy. What needs to be done? And the first step is the availability of pre-qualified equipment. Maybe there is nothing to do. I can rely on something that has been qualified in the past, and that would be perfect. But unfortunately, most of the time, it doesn't work. The next one is, if you try to make it only by analysis, might also not be working. Then you need to define, should I make a mix between analysis and test? What is the mix? What should be performed by analysis or by test? It's also something where experience is quite key. Then you need to decide on the specimen. If you have something to test, you need to define a specimen. The specimen is not systematically exactly the piece of equipment that you will have finally. Sometimes it's due to the dimensions. You need to define a specimen being representative of what needs to be qualified and what will be placed in the plant. And taking the decision on what is the right specimen is also quite difficult. And for this, we are having quite extensive knowledge on Framatome side. And then you have the number of test sequences, the hold and witness point. You need to define what will be the involvement of third parties, of the safety authorities, and so on. And these are all aspects that are playing a role also in the timeline. And experience on that is key. So going further on, appropriate technical resources. As soon as your strategy is done, you need to go to the lab if you test. You need to test something. So there you have the question of the accreditation. Accreditations can be defined already at the level of the safety authorities, or there is requirements in the contract. So you need to gather all the information to know precisely which kind of laboratory you can, where you can perform the test, and to do the necessary if the necessary laboratories are not accredited. You need to check the availability. You need to consider the pre-aging. You consider, for example, an accidental situation after 20 years, but you have not 20 years to perform the qualification, so you need to stretch it. You need to accelerate the aging. And this is also something on which things can be going wrong. And you need to consider the material that will be pre-aged. And here, once more time, the experience is quite important. And then the qualification of the suppliers is also one very important aspect. So if this is done, we can move on. And on the studies, test, audits, management, we can provide support to the suppliers that are not used to perform this kind of qualification. Suppliers sometimes were providing just a standard product without having the need to perform a specific qualification for a specific region in the world with a specific safety authorities. This is something on which we are used to provide support, and we can help you. Also, the use of verified, validated methods for the analysis. That's quite tricky because sometimes you open the contract and you have an amendment, a second amendment, and some methods are defined how to make calculations, seismic calculations, whatever you want to perform per analysis. And you need to be very clear at the beginning because afterwards it's too late. And here also we are having plenty of experience. So do not hesitate then to contact us. And also the very detailed level of qualification proofs is quite key. Otherwise, you will have missing elements in the final qualification file. So at the end, you have the demonstration of the compliance record. You need to track the configuration. If the manufacturer is modifying the equipment, then it's not qualified anymore. So the configuration and the changes needs to be tracked very accurately. And as soon as the qualification is finalized, in the theory, you can say, I launched the serial manufacturing of the equipment. But many times what happens is that the qualification steps are started too late, meaning that you have an overlap between the qualification not being finalized and the start of the serial manufacturing. And there you take the risk, if your qualification finally is not successful, that you can destroy all the equipment that have been manufactured. That's one of the key messages we want to give here, that the timeline is really key. Now, if we have a look a little bit more on the SMR, so you can see on the right-hand side, and Eric was already introducing it, it's a compact design. That's the design of the SMRs are quite different, so it's not only one design, there are very, very different designs so far. But basically, you can see on the right-hand side that, for example, the pressurizer is part of the pressure vessel, or you can see also that the steam generator are also integrated in the pressure vessel. So the idea is to be quite compact. And the challenge that is coming up in comparison to the standard light water reactors is that you are having a smaller containment in SMRs in relation to the reactor pressure vessel volume. And this is having some consequences that we expect. The first one is that in a case of a LOCA or high energy pipe breaks, you will have a raise of the containment pressure and temperature. that is expected by logic to be higher than what we are used to expect in standard accidental conditions in light water reactors. And the second one is that the profiles that you expect, the LOCA profiles in the containment, due to the fact that for SMRs, more passive systems will be used than compared maybe for today's, nowadays, light water reactors, that the profiles will last longer at high temperature and high pressure. And this is also something to be considered. So basically, we could expect, without talking now from a specific SMR design, that the LOCA profile in the containment will not be covered by the present qualifications in standard light water reactors. So consequences, you can see 3 of them. It's first, the need to pre-select, so the need to check the pre-selected equipment for a specific SMR and the equipment to be located inside the containment. You need to check, due to the increased condition in accidental situation, if the equipment pre-selected and their qualification are covered by these new requirements. And we fear, in many times, this will not be the case. Maybe sometimes you perform the qualification being very conservative. So you had, I don't know, 50% margins, you considered 3-4 bars more in the containment and, I don't know, 100 degrees more. Maybe then you could have the chance that it will be covered. But most of the time, if you do that, you take the risk to fail in the qualification. So many times, I think, it will not be that much, it will not be covered by the new requirements, and then you have a delta. And then you need to go in a qualification process, either by analysis or by test, but you have a delta. And you need to perform this de-risking assessment. The second one is related to the fact that you will need, if you need to perform tests, you cannot do everything by analysis. You need to perform these tests at local conditions being higher for the test facilities than what we are used today. So it means the test facilities need to upgrade his local chamber, for example, to be able to go at higher temperature and higher pressures. That's not the case in most of cases. It's not the case today, because even all the profiles are not available. But it's something on which, on LOCA's, on Framatome side, for example, we are having the facilities and we are having the possibility to improve these local chamber conditions, so to cope with the SMR local conditions. And the third one is related to the usage of passive systems. It's definitely a progress, and it's more safety being behind the SMRs with more passive systems. But you need also to validate these passive systems, because when the local profiles are calculated, you make assumptions on the efficiency of the passive system, but they were never used most of the time. They are new concepts. And on this aspect also, I will show that we are able to help to validate the codes by realizing such loops that are testing these passive systems. So here, this is the one aspect on de-risking measures. And you can see that for the pre-selected equipment, I mentioned it before, we are having an equipment qualification databases that is encompassing all the qualification files we performed in the past. So the first step we would recommend to you would be, you take the list of the equipments to be in the containment and you compare with what has been qualified so far. This is what we will do, at least on our side. And we will see where are the gaps. And if you know the gaps, then you know what is next to be done. We have seen it. Understand the requirements, prepare a qualification strategy, and go quite quickly in the qualification process. And for this, we are thankful to have really decades of experience that we can provide to you. Because never forget that, for example, for a typical K1 qualification, it takes 2 to 3 years to get it successful. And sometimes it fails. So it's really something to keep in mind. The consequence number 2 on the left side is related to the upgrade of the local chambers that will be needed to cope with the SMR local conditions. And on this, you can see some example of the vessels that we are having and the powers that we can provide on the Framatome Technical Center side. We can provide the advice on the appropriate boiler vessel combination. You comes with the profile and we will make a recommendation. what should be done on our side. We will prepare and validate the setup towards the transients and loads to be run before going really in the qualification itself. And we perform the pre-study or the study to validate the control system. That's also quite important. And then finally, we can perform the qualification test. So this is something we can provide as soon as the local profiles are defined. And the last point, the number 3, is related to the passive system. So here you can see some pictures from the site from Framatome Technical Center in Karlstein. And there is a list of some of the passive systems we were already testing in the past, but for other designs, not for SMRs automatically, but for other designs, but that we can adapt. And you can see one example of a quencher on the right side. So this is where there is a big bubble. And it's providing the possibility that if there is a steam release in a containment, for example, to condensate the steam with this quencher. The design is key. There's a lot of knowledge behind that we gained in the past. And this quencher is also something that we could provide as a test facility, like said before, to validate the codes that have been used to calculate the local profiles over the long run. So minimize qualification risk by relying on an experienced partner in the field of qualification, and just then give a call to Equali, engineering testing of components and passive system operating integral loop. So we have, and I think it was well shown by Eric, we have a broad palette of possibilities. We are very flexible, and that's the way we want to address it to you. So to summarize, like you have seen, we can expect for AMR, SMR to get increased local conditions in the containment. And for these reasons, pre-selection, after the pre-selection of the equipment, a de-risking assessment will be needed. That would be the first part. If the qualification cannot be overtaken or cannot be fully performed by analysis, we will need to perform local tests with local chambers having been upgraded to cope with local conditions. And finally, we propose also the possibility to provide the testing loops for the passive systems that will be considered, so to confirm the code calculation having been used to calculate the local profile. In any case, anticipate, because afterwards it's too late.
Yeah. Really, just a few words to not so much close the conversation, but to summarize some of the challenges here. So you need first to consider the specificities of multi-module plant design, because this will generate new risks that you do not maybe have on the single or 2-unit design. You need also to assess the common cause failure modes, which sometimes are completely new and shared systems that can lead to accidents occurring in a reactor module as well as in other modules. This is quite new as well. Identify the new system structures and components that are not used in conventional large nuclear power plants, and which may have new failure modes. Testing to acquire empirical data for correlations, as well as materials testing to support code development and knowledge about corrosion effects and so on. And as well as advanced manufacturing techniques, which are considered by some suppliers, which will also create a need for more qualification and more testing. So that's, I hope we've succeeded in maybe raising your awareness or opening some eyes on the importance of equipment qualification in the SMR context and the challenges with that. That's it for us. I think we'll be ready to take questions. I'm not sure this is in the same room, or we're moving to the next room, and then we can engage discussions with those of you who have questions. Thank you so much for your participation. Thank you.